okay?
recording ah?
Maybe where's my car? Like that how? Go down. You start already ah? You start already ah? I will see what I can do. That's what I say okay, I start already. Let's start. Okay, just now I gave something, right? Okay, so if it's spoiled, what should I do now?
Very fair.
No, you sit down first. My camera is spoiled. The stand is spoiled.
Then use the pen lah，你这样卖给你啊。
warranty.
No, the thing is that your cost is fine. Your car will have it, but my 104 how?
他借你
You
啊，
think 有好玩啊？
他低价低价了。
可是他们坏我会哭哎。
就是咯。And the cost very prone to accident one, no?
Is it this one is discount for right?
This one is the school one.
As in like before you come here, you will go.
They 104 got no maths, that's
That is us ah.
yeah lah.
Never mind lah. Plus one from ground for next plus one by one.
What's the don't talk again? Okay, come. Let's start. Okay, after that you take out the camera from me. I'll ask Daniel to do it, okay? Alright. I go on when the camera is quite up. Okay. Now, just now I gave question 10, 12, 17 and 18, right? Now, all these, can you please do it at home, okay? Even if you have not finished, you do it at home. Tomorrow then I will go through. Is that clear to everyone? Okay. Now I'm going to start the next section on scalar multiples of the vector. Okay. Now, let's take a look at what we have here. I'm going to introduce to you first, alright? Now everybody look at the board. Scalar multiple, okay? Now, if this is A, right? Hello. I think everybody knows already. If it's the other direction and same length, it's negative A, right? Everybody okay? Now, what if it is the same direction but twice the length? So it will be 2A. Everybody agree? Okay, what if it's 3 times the length? So it's 8. Okay? Now, what if it's in the same direction but only half the length?
A over
So it will be half A. Okay? You don't divide vectors, you multiply by a scalar. Understand? So half A. Now, what if it's the other direction but also half of it? So negative half A. So this is what we mean by scalar multiple of a vector. Do you understand what I'm talking about? Okay, a scalar multiple of something must be parallel to something, am I right? Just that it might be in the opposite direction, that's all. Okay, they must be parallel, okay? Alright, now let's take a look at page 194. In section 5.1, we learned that two vectors are parallel if they have the same or opposite direction, but they can have the same or different magnitudes. Now, you look at the picture that they show you, okay? We observe that A is actually 2B and so on and so forth. 2B and 3C are called a scalar multiple of B and C respectively. Now, from the diagram that I've drawn here, right, class look up. Do you agree that 2A and A and negative half A and so on, they must be parallel? Correct. They must be parallel. Agree, class? Okay. Which two has the same direction? 2A and A, right? Okay. A and negative half A will have different direction, but they are still parallel. Do you understand? Just that they point in the opposite way. Everybody okay? So this is called scalar multiple. Okay. Now next, look at page 195. In general, if A and B are two non-zero and parallel vectors, then A equals to KB for some scalar or real number K not equals to 0. So in other words, they are giving you some of the things down there. Now what it means is this. If, let's say, I have a vector A, if something, another vector is a constant times A, definitely these two will be parallel. Regardless of whether k is positive or negative. Do you agree? If k is positive, that means it's in the same direction. If k is negative, then it's in the opposite direction. It can also be fraction. Fraction means 3.5 means 3 times and then half a times. Is that clear with what I'm talking about here? So, if I want a vector that is parallel to D, it will be just maybe MB, right? Where M is a constant. It can be a positive or negative number. It can be fraction as well. Doesn't matter. Everybody clear? Everybody clear? So, as long as I can prove that one is a multiple of the other, they are parallel. Maybe? Yes or no? Now, then there's something here. Last time we did this also. How to prove that 3 points are collinear? What's collinear? The 3 points lie on the same straight line. First thing you must prove, they are parallel first. Parallel means already proved gradient the same. Agree? Now in vectors we don't talk about gradient, we talk about parallel. Am I right? Okay, so if you want to prove 3 points are collinear, first thing you prove they are parallel first. Then there must be a common point. Agreed? So that they can connect together. Remember what I told you? Okay, now, what do I mean by that? Because vector straight away, one of the questions will be, does 3 points are lie on the same line or they are collinear? Now, if I have A, B like that, and I have C, D like that, do you agree that from here I can only conclude that AB is parallel to CD? Yes or no? The vector AB is parallel to the vector CD. But are they lying on the same line? No. Unless I have maybe one common point. Maybe this one is BC. Now, if the same point B, that means it will connect here, right? Then you will move up again. If they're parallel, it will lie on the same line. Agree? Now, does it mean that this point has got to be C or have to be B? It doesn't mean that. It can be what? Can it be AC? Okay, right. So you just here overlap, right? Then move. It's still lying on the same line. So as long as there are 3 points, right? Okay, one of them is common, can already. Do you understand? Like for example, 3 points. A, B, C. Yeah? So it's either A, B, B, C or what? A, C, B, C also can. Then C is the common part. Understand? Or A, B, A, C. Then A is the common part. Okay, either of these 3 is a common point. Then they are collinear. Understand? So for collinear must have 2 conditions. Number 1, what is it? Parallel first. Number 2, there must be a common point. That's it. Everybody okay? If not, they are just parallel. Right? Okay, so this is for this part here. Alright, now, next, let's look at page 195 in the middle. In figure 5.9, in terms of column vectors, so on and so forth, okay? Moreover, so on and so forth, and then so on. Now, in general, that one just read through yourself. Look at the box down there. If A is xy, then Ka will be kx, ky, right? This is according to matrices, okay? Then, mod of Ka will be mod K, mod A for any real number K. Alright? Now, what does that mean? What does that whole box down there should be? I'm going to explain to you now. Now, for example, I have A. The magnitude of A will be like that, right? Written this way, right? Okay. Now, what if I have 3A? What's the magnitude of 3A? The magnitude of 3A, right? Alright, now, do you agree it's the same as 3 times A? When I put a mod here for 3 means what? I take the positive value, right? Okay, now what does it mean now? If I have negative 3A, I want to find the magnitude of negative 3A. What will it become? It will still be like that. A, right? What is the mod of negative 3? 3, right? This is still 3A. This one is also 3A. What does it mean? If I have 3A and negative 3A, just the direction is different. The magnitude is the what? It's the same. That's why when I mod it, right? When I take the magnitude, right? Can you see it's 3A? This is the meaning. It doesn't mean any special function or any magic down there. Do you get what I'm talking about? Okay, if you cannot understand, I repeat again. One more time. If I have B, let's say, right? 2B and negative 2B. What's the difference? What's the meaning of from B how to get to B? Twice, right? Do you agree that negative 2B is also twice? But it's just opposite direction. So if I take the magnitude of this one, do you agree actually they are the same? The magnitude is the same, right? Now you learned modulus before. So this one I can say mod 2 mod B, right? Correct. This one will be what? Mod negative mod B, right? So mod negative 2 is still 2. Agree or not? Actually I don't have this one. It's just 2. Remember modulus always have the positive value. So this just means that if it's a negative, it's the same as the positive magnitude. Just that the direction is different. Everybody clear? Okay. So just take a look at the mod A. That means they want you to know this. KA, right, is mod K, mod A. Can you see that? On page 195. Everybody clear? Clear already? Okay. Now let's take a look at example 12. This one, I want to teach you something that the textbook is always very confusing. I don't like. I want to give you a shortcut. All the ways. Wow. Let's take a look. State example 12. Now this one looks simple, but when it comes to proving, everybody will don't know how to prove. State which of the following pairs of vectors are parallel. Okay. You look at this one. 6, 8, and what? 3, 4.
Yes.
Now, do you agree that this one, this one I times 2, I get here, right? That means 6, 8 is actually 2 times of 3, 4, right? Since this is a scalar multiple, these two are parallel, right? Agree? Okay, now, alternatively, you can do this, okay? Oh, look up. You can say 6 over 3 is equals to what? 8 over 4. Do you agree that it's 2 over 1? It's the same. Okay, this is when we are solving, it's very good. But when you prove that they are parallel, you must show this. One is a scalar multiple of the other. Do you understand? If you cannot find this constant, then you cannot. It's not parallel. But this constant, I must warn you, it need not be a whole number. It can be a fraction.
Oh my
That
god.
is even worse. Am I right to say that? Okay. So actually, how to find the constant? I teach you. Do you agree that from here to here is 6 over 3? It's 2, right? 8 over 4 is 2, right? So once you confirm like that, then it's already parallel. So it will be 6 over 8 equals to 2, this one, right? Okay. Now, supposing they say like that. This one and this one. Are they parallel?
Yes.
Can you tell? Can you tell by looking? I know it's yes, but you cannot tell by looking, right? So what you do is this. You go and take 1/6
Over 6 times 6.
over 6. Not equal. 1/6 over 6. So this is actually 1/6 times 1/6, right? So what is this? 1 over 36. Okay. Yes or no? How about this one? 4 over 3
Times 1
over 8, right? So 4 over 3 times 1 over 8. So this is 1, this is 2. Still, can you see that it's 1, 8? Did I make a mistake?
Yes.
I made a mistake, wait.
No.
I made a mistake somewhere. Oh, this should be a 1. Do you agree? Okay, this should be a 1. That's why I made a mistake. Balik. Count. Wonder is wrong. See, this set question also can set wrong. Okay, let's try over again. 1 over 6 divided by 1, right? It's still 1 over 6, correct? Then 4 over 3 divided by 8 is 4 over 3 times 1 over 8, right? So can you see this is still 1 over 6? Everybody okay? Now, it's either two-way. You say this one is equals to 1 over 6 times this one, right? Correct. That means this one is a scalar multiple of this. Or what can you say?
6.
is 6 times. Also can, right?
Yes.
Do you all agree? Okay, can you see that it's just the flip, the inverse of it, the reciprocal of it? Do you understand what I'm talking about? So as long as you can show that one is a scalar multiple of the other, they are parallel. Okay, class? Can or cannot? Can, huh? Okay, good. Now, let's look at part 2. Part 2. Are they parallel? Let's take a look. 8 over negative 6, so it's actually 4 over negative 3, right? So this one is negative 4 over 3. Do you think they are same? The same. So they are parallel. Agree? The third one, how about 15 and 15, negative 6, negative 5 and 3. Now this one over this one is what? Negative 3, right? How about this one over this one? It's negative 2. Are they the same? No, so they are not parallel. Everybody clear? Everybody clear? Okay, huh? Now, so, part B. Part B is a very general question. Now, I know you're tired, okay? I'm finishing it. Write down 2 vectors that are parallel to this.
What's the wrong?
This one is a very simple question, okay? Write down 2 vectors that are parallel to this. One in the same direction and one in the opposite direction. In the same direction, I can have negative 10, 4, right? Right. I times 2. What if I want something in the opposite direction? You can have 10 minus 4, right? The other direction times 2. Or you can also have what? 5 negative 2, right? So it will be direction 1 time. Everybody okay? Can or cannot? So there are many answers to this. Everybody clear? Okay, now I want to look at the practice now 12 at the bottom, page 196. I will look at question 2. All of you look at question 2. I'll give you a shortcut to do the question.
Minus 9.
Because I don't like the way that they present it. One scalar multiple straight away everybody fit. Okay. Given that 4 minus 3 and 12p are parallel vectors, find the value of q. Sorry, find the value of? That means straight away is 4 over 12 equals to negative 3 over p. Understand? So 4p equals to negative 6. P will be equal to negative 9 straight away. That's how you get the answer straight away. Do you understand what I'm talking about? This is the fastest way to do it. Okay, don't go and say, oh, I want to write in scalar multiple. After that, don't know which scalar to use, they're all wrong. Understand? Can you take this down? Can you take this down for practice now 12, number 2? Okay. Next up. Are you all okay so far? Are you all okay? Okay. Alright, now let's look at example 13 right now, page 197. Now this one I'm not going to go through that much because it's basically your matrices. Okay, let's take a look at the first one. If A is 7 minus 5 and B is minus 2, 4, express 2A plus 3B as a column vector. Easy, right?
Yeah.
I told you already, yes, you can do this morning test, you can do this one. Am I right? Okay, next. If U is x4 and V is minus 5y and U minus 2V is this, find the value of x and of y. No problem, right? Just make sure you solve the equation, right? Form properly and solve the equation. Okay. Now next, I need the visualizer. Okay, how? I want you to look at page 198 all the way to 199 first. All of you. After that, then I'm going to do position vectors. Then I'm going to stop and I'll do homework together with you. Okay? If I want to buy a tripod, where do I go to buy?
Square.
Huh?
Square.
Oh, wait.
Online is
No, I want it by tomorrow.
笑，那要去 CV Square 啊？
immediately buy, immediately carry back.
Please, you.
I know finish there for as long as got camera have already. This is F file already. I don't have F file.
Tomorrow 是一次算完。
Yeah, sec
Tomorrow
one.
got F 啊
I don't know.
Every day got
also
one.
have.
Ask can you
Ask
how much?
media
Ask media.
Oh yeah, media come vice president. Yeah.
Later, Mr. Paul told me I'm very scared.
Never mind. But Mr. Guo is like
Mr. Media Club, one.
vice president.
You're the vice president. You got, because Mr. Paul was slow, right? Who's Mr. Lau? I do Lau also media club, man. Oh, shit, I don't even know. Okay, never mind.
You ask, he won't
老
scold.
师啊，
You ask, he won't scold. They ask, then you will.
汤老师就 drone 而已。
Yes, Johnny.
The whole time your hands are scolded. One
Let
finger.
me also spoil, you know. Must buy 10 extra one. Then one spoil, throw away, then use the other one, then throw away. Every time this one, don't have this diary, gonna start inside. I think I know what I take some boxes, then put the camera on top.
Yeah.
right? Boxes spoil, I can take from downstairs, ma.
飞机倒下来的，他一直在骂谁啊？
You stand there, stand to your head. Tie to someone's head. What rubbish you telling me? This fella is terrible. Okay. I want to show you this one. It's actually quite simple, but the thing is that some students will have problem visualizing this. So I'm going to show you on the visualizer, it's easier, okay? Alright? Don't have to go and memorize this, just bang right here. Okay, now take a look at this picture. On page 198, everyone. We have learned that the sum or difference of two vectors is also a vector. So can we do the reverse? That is, can we express a vector as a sum or difference of two other vectors? Now you look at this particular question. They give you a vector AB, right? Then they ask you, can you draw this and this such that when you add together, it becomes AB? That means how many times of V do I need and how many times of U do I need? Do you know what I'm talking about here? This is the question. Okay, now you turn to the next page. They show you how to draw. There are a few ways to draw it, okay? Now, you look at the first way. Alright? What this fellow did was, can you see that this AC is actually parallel to U? Can you see? Okay, now you look at this one. It's 1, 2, right? So this one is how much?
1.
1, 2, 1, 2, 1, 2. Can you see that this is actually 3U? Can you really see that this is actually 3U? Okay, I use a thing and I go over it.
像来
What's that?
Flying.
Oh, thank you. Do you agree that this is actually 3U?
Yes.
Can see it? And it's parallel. Now, this one is 1 time of V. So, may I know how many times of V is this? 2. Huh? 2, right? 2V, right? So, actually, AB is 3U plus 2V. You agree?
Yes.
That's how we see it. Everybody okay? Alright, so after we draw this, then you look at what they did. They do it this way. Can you see it's exactly the same as what I have drawn in red just now? 3U plus 2V. Understand? Okay, now, this is the first way to do it. Now, what is another way that we can do it? Can you see that I can also draw it from the bottom? Can you see it? Okay, now all up here. This one will be your V, right? This one will be your 2V, okay? This one will be your 3U, right? So it's still the same, agree?
Yeah.
Can see? So I'm breaking this one in terms of two vectors. Do you understand what I'm talking about? So what does it mean? Just now it was 3U then 2V, right? Now it's 2V then 3U. So it actually shows that 2V plus 3U is the same as 3U plus 2V. They are commutative. I can switch around. Everybody clear with what I'm talking about? So this is what we mean by expressing a single vector as a sum of two vectors. Everybody knows what I'm talking about here. Okay, so this one is very simple as shown in the book. Alright? Now, next, can we look at page 200 now. I know you are tired. I'm going very slowly with you.
Yeah, tengok.
If I never accelerate, that means you must be thankful already. Okay, it's constant speed. Alright, I never decelerate, but let me tell you this. Okay, if I decelerate,
just say you slow down.
I never slow down. I slow down means I go back to the normal speed.
Oh, so that's
If not, I will accelerate. Okay? Now, let's look at page 200 at the bottom. In general, any vector AB can be expressed uniquely in terms of two other non-zero and non-parallel coplanar vectors in AB. Coplanar means they lie on the same plane. Now, you know what's a plane, right? Not the aeroplane.
Singapore Airlines.
Not Singapore Airlines. Now, when we say that, next time you will do, when you are in JC, you will do. What do you mean by same plane? Now, the floor is a plane. That means it's on the same level. The board is also a plane. Okay? Now, but the board and the floor are not the same plane. That means when I draw here, it lies here, cannot lie on the floor. You understand? Now, then you will ask me, next time do we have lines or things that lie on Darren, are you trying to hide that you are sleeping? You want to create a plane, right? You're blocking me with an opaque plane. Okay? Now, what happened is this. You see, if two lines lie on the same plane, when I draw, they will intersect, right? Now, you see, if I have one line like that and one line like that, you know that they lie on different plane. They will never meet, you know. Because there's a distance between them. Can you see? They will never meet, yes, correct. Now, actually, there's a name to this. This kind are called skew lines, not skewers. These are called skew lines. That means they are lying on different planes. Do you understand? It's called skew lines. Skew lines never meet. It's very sad. It's like two person walk right but never meet. 向左走向右走. That kind of thing. But of course, you say the earth is round, right? So they 走来走去. Then you will meet somewhere, right? But by the time they meet, I think they're 100 years old. Okay, so too bad. Okay? Alright, so that's it for this part. Are you okay so far? Okay, now look at the box down there. AB will be MU plus NV depending on what is the length that you have drawn. Is that clear? Okay. Now I'm going on to the very important one. That's called position vectors. Can you see what I mean?
Yeah, the 5C is just behind.
Yeah, you know 5C is just one page away. That's it. Okay? I will accelerate, don't worry. I'll accelerate when it comes to A-maths.
Huh? Oh yeah.
Don't forget I still got A-maths. Okay? Okay, come.
Huh?
How many more chapters for A-maths? 5. 5 for O-level, 3 for here. Papaya is like that.
That's fair one.
Papaya look about the same one.
Papaya got the whole one.
Orange. Orange color so is papaya. You don't understand this boy. It's so amusing.
That's a pear, right?
It's a pear. I thought pear is like that.
Guava,
You're
guava.
doing the same thing.
Very good. What's the meaning of similar?
Dimension,
This one. Last time, was student, right?
Oh yeah, also yeah.
I thought rambutan is
The
smaller
hairy,
than-
hairy, yeah. The speed.
This is your
Last time when we
hair.
were students, right? Keep quiet. I'm not
Yes,
if I can draw right, then I will not be teaching maths anymore. I can be like Leonardo da Vinci or
I
whatever.
thought you say you draw giraffe like draw cat.
I draw, but I know never sell. You think I draw people will buy me?
we
People
buy.
one picture sell for a billion. I one picture don't one cent, other people want to buy. See, I draw one papaya, people also say it's pear.
That's why
How to sell? You tell me.
Depends on your perspective.
Perspective,
Yeah,
That's why I think if I ever be an artist, I want to be abstract artist. Too abstract, you're not too hard. Isn't it wonderful? Just like a look. I know how to do. I just like that. Then the whole thing blank, right? Then the
future. B to A1, B to A1.
Oh, this is a
万绿
2024.
丛中一点红啊。I will say, oh, this is my blood comma. After I mark A match, one start for then I will say this is called my 心血. You get what I mean?
哎喂，but then the people is white 我万绿丛中，我万白怎么
Okay, 万白咯。万白
You know, right? Bye.
丛中一点红. Okay.
呀？
Everybody
Oh.
I'll buy.
I don't know why you all are so happy when I'm not even drawing vectors. Okay, now position vector. Don't talk rubbish. I'm trying to waste my time, right? Then no homework, right?
Oh,来来来，
Ah.
不要理，
I talk rubbish. Come, let's see.
哎，already have homework already. The homework
The
already.
one is not gone. Okay. In section 5.1, we have learned that we can express a vector line on Cartesian plane as a column.
呀，你บอกสิ
Okay, PQ is 4, 3. We can draw another vector 4, 3 on the Cartesian plane with a different starting point. Now, for example, blah 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 blah. Okay, now, when we say position vector, it's very important to me. Okay, everybody listen up. When we say position vector, it is taken with respect to the origin. That means the origin 0, 0. It must be drawn on the xy plane. Xy plane is also called Cartesian plane. Understand? Okay? Now, let's take a look. The rest you can read through it yourself. Now, do you agree that PQ is OQ minus OP? Yes, yeah.
Yes.
Okay, now, for position vector, it's always O. Because it's with respect to the origin. O. Understand what I'm talking about? Okay? Now, then there is something that's important. If P it has coordinates 2, 5 and Q has coordinates 6, 3, then the position vector OP is 2, 5. The position vector OQ is what? 6, 3. That means you can convert coordinates to position vector if you are taking 0, 0 as the point of reference. Understand? That's why it's position. Just now what I said, you can start any dot, right? Remember? I said you start at any square you draw, as long as they're parallel, they're equal, right? But when we come to position vector, it is with respect to the origin. So you cannot anyhow draw already. Understand? You must take reference from the origin. Everybody clear? Okay? Alright, good. So you look at page 201 at the bottom. P is 2, 5 and Q is 6, 3. Then PQ is OQ minus OP. So they will use the position vector and then they will get this thing down there. Understand? It's just some matrices. But I will tell you what is it when we go on to more questions. Okay? Now, can we look at the next page? In general, the position vector PXY is OP, which is X coordinate on top, Y coordinate below. Now, let us practice again. What if R has negative 4, 6? What is the position vector of R? No, what must you write first?
OR.
It must be OR. Will be what? Negative 4, 6. Like that. Understand? So, if I give you this, I must be able to find this. If I give you this, right, I say what is the coordinate of R? You must be able to give me this. Understand? You cannot say that. Coordinate is so obvious, you cannot see that. I cannot see. You must write. You understand? This is called column vector. This is called coordinate. They are different. Everybody clear? Okay. Alright, good. Next. As mentioned in section 5.2, is regarded as a movement, so on and so forth. I think you should know what is this. Okay, no problem. I'm going on to the last example. Would that be okay? Last example, huh? Alright.
But Michelle, why cannot start at any point?
Because when you start at any point, it's no longer a position. You don't know with respect to what. Then you cannot say it represents a coordinate anymore. If let's say, you see, if I have PQ, right? Everybody look up. If I have PQ equals to, let's say, 2, 3. And then AB equals to 2, 3. They're actually equal. Am I right to say that? That means I can draw from the square box. I can start any point, right? 2 and then 3 here. So this will be my PQ or my AB, right? But with respect to position vector, there must be a certain OP and certain OQ. That means you must plot with respect to your x, y coordinates. That's why you can get the coordinates from the vector. If you like that anyhow, right, you cannot get the coordinates from the vector. You understand? Because there's no point of reference. Do you understand? I said I travel 30 meter. You can hear here 30, there 30 all equal. If I say I travel 30 meter from here to this direction, then you know exactly where you are with respect to which point. Everybody clear? Okay? Alright, now let's take a look at example 14, the last example. So, position vector is with respect to what? Origin. Okay, very good. Not original, huh? Original Kentucky have, huh? Okay, let's take a look at example 14. I'm going to go slow here. Write down the position vector of P, 2, -3, and of Q, 4, 1. Okay. How to write position vector of P? Oh, look up. This one, it come out in exam as a gift from heaven.
OP.
OP will be what? 2, -3. OQ will be what? 4, 1. The worst thing that can ever happen is you do this.
Is it the same thing? Oh, wait,
That's coordinates.
Do you think it's the same thing?
No.
No, please go now. What's first, do fraction, do until gila already, right? All do fraction.
I did it yesterday.
Always like that one. I don't understand why. Then suddenly the one line down there don't know for what. Then after that, I realize it's wrong. Then after that, too late already, no? Oh. After the exam, then we realize. During the exam, we'll not realize what. Okay, then next. Then express PQ as a column vector. Okay. What's PQ? O. OQ minus OP, right? Agree or not? So what should this be?
OP must be. So you
4, 1 minus 2 minus 3. Answer? 2, 4. Can you see that PQ is just 2, 4?
Oh, yeah.
Everybody clear? Okay, alright, now next. A point A, 5, -5, 3 is translated by the translation vector AB, 9 minus 6 to the point B. Find the coordinates of B. Okay? Okay, now, you see, a point -5, 3 is translated by a translation vector AB. AB is what? 9, -6, right? Okay, to a point B. Find the coordinates of B. Okay, this one is something that students always get confused with. Okay, now let me just give you a coordinate plane. Don't look at that one first. What do you mean by a translation vector? Okay, everybody look up. Now, supposing I have a point A here. I say I want to translate it with 2, 4. Where should it go? 1, 2, right? Then 1, 2, 3, 4. Should be here, right? A go to there, right? A prime, right? Agree? Now the thing is this. A is here, is translated by this. I want to find out where is point B. Okay, now everybody look up. Do you agree that this one means OA is -5, 3? Yes or no? Okay, now then everybody look up. AB means what? OB minus what? OA, right? Everybody okay? So what's AB? 9 minus 6. OB don't know, right? Okay, minus. What's OA? -5, 3, right? Everybody okay? So can